Hello, geometry students. Mr. Fugay again, and this is the second part of our ratios and proportions lesson. For this part, we're going to talk about proportions. Just like part one, this is going to pertain specifically to what we're going to be using proportions with in geometry. So if you would like a deeper dive into what a proportion is, I have another Math Antics video off here to the right, roughly about 10 minutes long, where he will talk specifically about proportions and go into a little bit of a deeper dive than what I'm about to do right now. But let me give you a quick overview. So a proportion is a pair of equivalent ratios. And what we need to add to that is that these ratios must be in the same units in order to write them in proportion. The main goal of proportions is, of course, to find a missing quantity, something we don't know, but we have a ratio that we can set it equivalent to. So a quick example here is I have an RV traveler who says they can drive 1,645 miles in 1 week. Guys, that is a ratio, okay? That is considered a ratio right here, and we know both parts of that ratio. What we need to find is we need to find how many miles can they drive in 4 days. So that is the unknown part. This is the other ratio. So what we're going to do is we're going to set it up as a proportion. So we're going to have 1,645 miles over 1 week. There's our first ratio. And we're going to set that equal to, well, we don't know how many miles, so we'll call that x, over, and then 4 days. Now, the other part of this definition that I said is that the ratios must be in the same units. So just to confirm, here was the yellow ratio, the one that was given to us initially in the problem. And then the blue ratio is the one that I'm trying to solve for. But our major problem right now is the fact that this unit is in weeks and this unit is in days. The numerator units are matching. They are both miles. So we're okay with that. But because the denominator units are incorrect, we need to convert one to the other. As I mentioned in part one, it's always easier to take the bigger unit and convert it to the smaller unit. So 1 week, instead of calling it 1 week, we're going to go ahead and erase that. And we're going to say instead that is equivalent to 7 days. And so now we have created two ratios that are in the same units and they are equivalent to each other. Now we're going to solve. And when we solve, we don't have to worry about the units. We're just going to focus on solving in the math. What we use is a process called cross multiplication. So I'm going to cross multiply these diagonal terms, 1,645 and 4. That gives me 6,580. We're going to set that equal to the other cross product here, which is going to be x and 7, or just 7x. To solve then, we would just solve the equation by dividing both sides. And so my final answer here, when I divide that, is 940. So the final answer for this example problem is that the RV traveler would go 940 miles. Now that we know that, let's go ahead and let's start talking about some of the solving techniques as we look at two examples here below. So once again, here's one that's already been set up for us, but we are going to set up by doing the cross product. So the first cross product, 1 times 3x, is 3x. My second cross product we need to be extremely careful with. Let me write it up here so you see what it is. We're taking 4 and we're multiplying it to the quantity x minus 3. So we need to be very, very careful in this situation to use something called the distributive property. So we're going to take and multiply that 4 times the x as well as the 3. And so when I do that, we get 4x and we get 12. All we now have to do is solve this equation. It's actually easier if I subtract the 4x from the other side first. So we get negative x equals negative 12. Divide by negative 1, x is equal to 12. Now, if we look at the second example, something else is going to come up that we need to discuss. So when I do my cross product, once again, we're going to multiply those blue terms. Once again, that is going to be the distributive property, x times the quantity x minus 4. That's going to give me x squared minus 4x. When I do my other cross product, I'm going to get 4 times 8. 4 times 8 is 32. What we might run into every once in a while is a situation with an equation that has an x squared. Looking back to what we've learned in prior courses like Prob Stat or Algebra 2, when we have an x squared, we're going to use what's called the zero product property. In other words, move everything to one side and set it equal to 0. So we're going to say x squared minus 4x minus 32 equals 0. And in this situation, we would need to factor this since we have an x squared and an x term. So let's go ahead and let's factor this out. I need to look for numbers that are going to multiply to give me negative 32, but also add to give me negative 4. Thankfully, there are two numbers that will meet this criteria, and that is the number 8 and 4. if I make the 8 negative and the 4 positive, when I multiply those two red numbers together, I would get negative 32. And when I add them together, I would get negative 4. So when we set up each of these to solve, we get x minus 8 equals 0, x plus 4 equals 0, and then we're going to solve these. So we get x equals 8 as one of my answers, x equals negative 4 as my other answer. So we're going to take a moment here now and have you pause this video. I have 4 different examples down here. One of them will be a quadratic. Some of them will involve distributing as well. But here are the 4 examples I would like you to try. Really important to take the time now to pause this video, go through and try these problems out, and I will have full solutions for you in about 5 to 6 seconds. Welcome back. Let's take a look at letters C and D. So for both of these, we just had to do our cross products. Notice I've denoted one of them in red, one in blue to help you check the answer quicker. So I get 80 equals 10x, divide both sides by 10, x equals 8. For the next one, we need to use the distributive property here for our red cross product. So 14 times y is 14y, 14 times negative 3, negative 42. Solve this equation by moving the 14 to the right, divide by negative 7, y is equal to 6. For letter E, cross product again, just a reminder that for the blue one, we will need to use distributive property, which you can see once we set that up, and subtract 2y to the other side, that y is simply equal to 2. Now I saved this last one because I wanted to talk about it with you. This one is another one that has an x squared in it and an x, and so we still want to use that idea that I mentioned called the zero product property. So we're going to move the 100x to the other side. And when I do that, I get 0 equals 6x squared minus 96x. Now, what makes this problem a little bit easier than the previous one is that there is no constant or numbered term. So unlike the one we did here where I got this trinomial, 3 terms, we only have 2 terms. And thankfully, when I look at this, we can actually pull out what we call a GCF. So I know that 96 does indeed go into 6. So I can factor out a 6x out of both of these. And by doing that, what I would get is x is my first term, and then 96 divided by 6 is 16 as my second term. We can now that we've factored this using that GCF property, we would say 6x equals 0, x minus 16 equals 0. And so the first answer is 0, and my second answer is 16. Okay, so that's solving proportions. The last element here is I want to talk about some properties of proportions. And this is really important because as we start to write our own proportions in the geometry course, I want you to understand that there are multiple ways to write a proportion, and all of those ways are acceptable if they follow one of these criteria here. So I have the properties listed across top here with A, B's, C's, and D's, but then down below I have a numeric example. So original proportion we're going to use for this example is A over B equals C over D, or numerically 1/2 equals 5 over 10. So the first property of proportions is that we can take that A and B and flip it as long as we take the other ratio, C and D, and flip it as well. So you'll notice there is our flipped property there. Numerically, what that would do in this situation is I would flip 1 and 2 to make 2 over 1, and as long as I flip the other ratio to be reciprocal as well, we would create another true proportion. 2 over 1 equals 10 over 5. The next property, called switching the means, is when we actually take the cross products A and D and switch them. That's what this first scenario looks like. Or if I want to switch the other cross product, that's what this scenario is looking like. So in our situation here, if I wanted to, let's say, switch the 1 and the 10 around, I could then put 10 would be first, 2 would stay where it is, and then 5 would be where it was, and then the 1 would go here. And as you might look at it here, we will see that 10 over 2 is indeed equal to 5 over 1. But if I wanted to switch the other cross product instead, so that means I would leave the 1 where it was, I would leave the 10 where it is. If we switch the 5 and the 2, we would get 5 on the bottom here, 2 on the top here. And as you'll see, 1/5 is indeed equal to 2 over 10. So when you're setting up a proportion, if you write it as a reciprocal, or if you write it where only one of the two cross products switches, you would create a viable situation. Now, the last one's the strangest scenario, so I want to talk about this very carefully. All right, so let me start by writing our original ratio that we have here. 1/2 equals 5 over 10. Now, this property is basically saying we're going to add the denominator to your numerator. Well, what I really want you to think about is how a fraction works. A fraction is a quantity that is being compared to a whole. So the denominator represents the whole. So for example, if I have 1/2 of a group of 2, I only have one of them. So when you add your denominator, you're essentially adding a whole to something. So in this situation, if I add a 2 here, that's the denominator that I have for the first one, what is the equivalent of adding a whole in the second scenario? Well, that would be a 10. And so when I create my new proportion, that would be 3/2 is equivalent to 15/10. And that right there is also a true proportion. So what we're going to do is look at an example where I'm going to write some of these a different way and then give you a chance to practice it. So if we look down here, in the next section, we're going to talk about how to write a proportion from a geometric shape like we're looking at here on the left. But you'll notice that in this problem, I already have the proportion written for you. So what I want to do is these first 3 is to write equivalent ratios that I'm seeing. So notice in the first one that the 5 and the x have switched positions. So letter A is definitely looking at the reciprocal property, so that the equivalent ratio would be 8/y. In the second example, in letter B, x is in the same position it was originally, but notice that the y moved down to be underneath the x. So this is telling me that we're switching those cross products around, or switching the means is what it's officially called. So that means that the 5 would then move up where y used to be, and 8 would stay where it used to be. So far for letter A and letter B, those are equivalent ratios. In letter C, we'll notice that the 8 is where it belongs, x is where it belongs, but now we have this plus 5. 5 just happens to be the denominator or the whole of that first ratio. So when I look at my second ratio, I'm going to write y, and then I'm also going to add what's the equivalent of a whole in this ratio. So that whole in this case is going to be 8. Ultimately, though, if letter D is going to have us solve the proportion, so I'll write the original one that we have. X/5 equals y/8. Since x is equal to 2, I'm going to go ahead and replace x with a 2, and we'll go ahead and we will solve this. 8 times 2 is 16. 5 times y is 5y. This time we're going to get a fractional or decimal answer because 16 divided by 5 is 3.2, or as a fraction, that is equivalent to, well, 16/5. So for our last set of practice here, I want you to look at here for E and F, that is, I want you to try to use this same property idea. So pause the video and try that out, and then we're going to end this lesson by putting it all together and talking about a Porsche. Quick examples. So for letter E, we'll notice that the 7 is now written at the top. So this looks to me that the cross products were switched of x and 7. So when I wrote that, I put the x down on the bottom and left the y where it was. For letter F, we saw this plus 2, which means I'm adding a whole from my denominator. So I'm going to add a whole from my second denominator, in this case 5. So that's going to give me a new numerator of 12. So x plus 2/2 is equivalent to 12/5. Okay, let's take a look at our final example here, and this is just putting everything together and kind of giving you a preview about where we're headed. So we have a Porsche Cayman S, has a length, real life length of 172.1 inches. Unfortunately, I can only afford a scale model that is in a 1:18 ratio. We want to know how long the model is. So a 1:18 ratio is telling me that the real thing, the real car, is 18 whatever, or 18 times as big as the model. So we would say a 1:18 ratio is comparing the model to the real thing. And since I know the real thing is 172.1 inches, I'll put that in my equivalent ratios denominator because I want to find the model's length. That will be my x. So we're going to go ahead and cross product. So 1 times the 172.1, and then 18 times x. Lastly, we would divide by 18, and so my final answer after all of that is going to be about, we'll just round it to the nearest tenth, so 9.6 inches is the real length of the model that we are looking at. So that's a preview of where we're headed when we talk about similarity in the next section. So that'll conclude our proportion video. Like I said, check out Math Antics, and this will, Math Antics if you want more review on proportions, I should say. But that'll conclude what we're talking about for geometry. So I hope you enjoyed the video. Thanks for watching.